Welcome to the Arithmetic Zone, and welcome to another simple Java video. Today, we're going to be looking at how to create arrays. So if you look into our Java folder, you may notice that I made a few changes. So the apartment class and its main method that I made in the last video, I put in its own separate apartment folder right here. And I made a new folder called arrays, and I made a file which we're going to be doing some work here today. You may also notice that right here, I have the written statement package arrays semicolon. This is done so that Java is able to tell the difference between the files in these two separate folders so that we don't end up mixing up variable names or class names. So just have that statement right there, and then obviously have your class header right here. We're going to make it public because we're also going to make some other files so we can run some methods. So what are arrays? Arrays are a class data type that can hold multiple values of a single primitive data type. So essentially we can have multiple integer values, multiple double values, multiple Boolean values, and even multiple string values, because strings are always the exception. So let's first make an integer array where we have a list of numbers. So I just created my main method right here. Now let's create an array. So an array is a class data type. So we want to allocate memory space for this. To do that, first thing you want to do is specify the data type that you want your array to be on. We want an integer array. So let's write int. Then to specify that it's an array, we enter hard brackets. And then after that, you want to enter the name that you want your array to be. So we're just going to call it ARR, short for array, then an equal sign, and then we want to allocate memory space. So we write the word new, and then int brackets. So similar to how we create objects of classes in the last video. Then inside of this bracket, instead of leaving it blank, we want to enter a number that's going to represent how many elements we want in our array. So if we want 3 values in our list, let's enter the number 3, then semicolon. Alright, so we made our array. Now our array is empty right now, and it has the default value of 0 for each indice. So if we want to change the values in our array, we have to reference each specific element by using an index number. So similar to referencing each letter in a string using the substring method, starts from the number 0, so we're going to have to reference indices 0, 1, and 2 if we want to change each element. To do that, enter the name of our array, so R, then brackets, and then inside the brackets is the index number. First element is 0, so if we want to change the first element to 5, that's what you would do. If I want to change the second element, I would reference index number 1, and then let's say I want to make it the number 2. And then finally, the last indice or last index number, let's change it to the number 10. And if we want to print the values in our array, one big limitation of arrays is that you can't just print out arrays directly. Like, I'm sure you think, oh, I could just do that, but if you were to run that code, you just get this random mess of character symbols, because this is a class data type that does not have its own toString method. We're going to look at another type of array later on where we can print it out like this, but for now we're dealing with simple arrays. So if you want to print out each value in an array, you're going to have to print out each element manually. And how can we do that? We can use a for loop. So for int I equals 0, and then I is less than the length of the array. So similar to a string, but unlike a string where it's a method where we use parentheses, for arrays, the .length method is actually an instance variable, so there's no parentheses there. So keep that in mind. So for every iteration, we're going to print out the current element. So R and then bracket I. So this is going to start from 0 and end at 2, because 2 is less than the length of the array 3. If we do it like this, now it prints out every element in the array that we specified right here. Now this seems a little tedious right now, but there's actually an easier way to initialize this array. Instead of allocating memory space and then changing each value manually like this, what we could do instead is have it all in one line. So after writing this statement, if you use the squiggly brackets and enter the numbers that you want, 5 to 10 separated by commas, then it functions the exact same. Doing it this way allows our code to be much shorter, and then we also don't have to specify the length of the array because Java can just figure it out by how many numbers there are in this list. As I mentioned before, arrays do have some pretty big limitations. Other than the fact that you can't just directly print them out, you also can't change the length of the array. So once I set it to 3 elements, it's going to stay as 3 elements. I can't remove or add another element to this list. And I also said that I can only use it for primitive data types, though strings are the exception. In a future video, we're going to look at a more powerful variation of the array where these shorthands are addressed. So a lot has changed between this cut and the last clip, but as you can see, I made a new file called array methods under the same arrays package. And in this file, I'm going to have all the methods of these algorithms that I wanted to show off. So in earlier videos, I would just delete all my code and just do one method at a time in one file. But now we're going to have all the methods in this file. And then if we want to test them out, we can reference and call the method in the main file so that we can keep everything. So let's look at this first method right here. It's called allPositive, and it returns a boolean, so either true or false. As the name implies, this takes an array, an integer array, through this parameter, and it goes through every element in the array. It traverses the elements in the array, and it checks to see if they're all positive. How does it do that? Well, it actually checks to see if it's less than or equal to 0, instead of checking if it's greater than 0, because if one of the elements is less than or equal to 0, it's going to return false. And that's the cool thing about return statements. Return statements can just completely stop for loops and just completely stop all this code right here and return to this main method right here. If this algorithm manages to traverse through the entire array without finding that any of these values are negative or 0, then it's going to return true. So that's the basis of that method. So let's test it out. So this returns a boolean, and to know if it works, we're going to have a print statement. So we're going to write system.out.println, and then we want to call this method right here. So how do we do that? Well, I now realize this should be a static method, because you would have to make an object of this class, but we don't really have to do that. So we're going to write array methods dot, because this is a static method, and then reference the method name dot allPositive, and then inside right here it gave me the default value null, but right here we're going to have our array. So I'm just actually going to I'm going to actually reactivate this code right here. So inside right here, I reference R. Now all these values are greater than 0, so this should give me true. Let's run our code to find out. And it gives me true. Now what if I make one of them negative? Say the last one gives me false. If I make the first value 0, it's going to give me false. So we know that our method works as intended. Here we have another method. It works similarly to the last method where I traversed through all the elements in the integer array, but this one has a different purpose. while the last one would return a boolean depending on if all the values are positive or not. This one is going to return an integer, and the integer is going to reference the index number. What this method does is that it takes two parameters, the array that you want to check, and then another integer number that you're trying to find in the array. If this number exists in the array, then it's going to return the index number that it appears at. But if it doesn't appear through it, which means that if it goes through the entire array without finding the number, then it's going to return the value -1, which usually means that the number you're trying to look for is not found. So let's test it out. So much like last time, this is another static method. So we reference array methods. And then this is a non-void method. It returns an integer, so we can print it out. But unlike the last method, this takes two parameters, an integer array and also the number that we want to check. So let's say I want to see if the number 10 exists in the array. And let me just, well, I don't really have to comment this out. And it gives me the number 2. Why? Because number 10 does exist in the array and index number 2. This is 0, this is 1, and this is 2. Now, what if I'm trying to check for the number 5? That would be the first one. So it returns the number 0. Now, what if I'm trying to find the number 6? This one is not in the array, so if I were to run the code, I get -1 because it went through the whole array without finding the number 6. Hence, it would return -1 because then it would never return the index number through this return I statement right here. Our third method works a little differently. This time we have a void method, so this doesn't actually return a value, but instead it prints out a value directly to the console. So what this method does is that this method takes the integer array, and it only prints out the values that are even. So it goes through every element in the array. It checks if each element is divisible by 2 with this statement right here, and if so, it's going to print it out. So this time I commented these out because, the number right here could confuse you. And because this is a void method, I don't actually need to use the print statement. I could just reference the method name, so even nums, and an R. Just like that. If I do that, it prints out 2 and 10 because those are the only even numbers in the array. Or rather, most of them are even. 5 is not even, so it doesn't print that out. Let's say I change this to 3. Only prints out the number 10. Let's say I change this to -1. Prints out nothing because none of these values are even. So we know that this method works. Now we're going to get into much more difficult algorithms. As I said before, you can't change the length of an array, but what we can do is shift the values over. So what I made are the shift left and shift right algorithms. So essentially what the shift left algorithm does is that it takes our array and it makes it so that all the values shift to the left. So 2 shifts left to the first index right here, and 10 shifts left so that it becomes the second element. Now the 5, because it's the first element, it wraps around all the way to the end of the array. So this would turn into 2, 10, 5 if I were to shift them to the left. Likewise, shift right, same idea, but it goes the other direction. So 10 is going to wrap around to the first element, 5 is becoming the second element, and 2 is going to become the last element. So this will become 10, 5, 2 if I were to use shift right. And it's okay if you don't understand how these algorithms work, but essentially what I'm doing is I'm returning a new integer array right here, and I'm making a new integer array and making it the same length as the array that the user passes through as the parameter, and then using this for loop where I don't exactly go through the whole array. So for shift left, I start from the second element because the first element is going to be the last element, which I account for at the end. And then using this statement, I shift them to the left. For the shift right algorithm, I do the same thing, but I start from the beginning and I stop short from the last element, and I make the last element the first element in the new array as such. So to test out this code in my main method right here, to test out each method, what I'm doing is I'm calling the methods and then I'm storing them into these new arrays that I'm making. So left array represents the array that I get when I use the shift left algorithm, and right array represents the array that I get when I use the shift right algorithm. After doing that, I print out each element in the array using the for loop, and then I separate the two separate algorithms with this blank print line statement so that you can tell the difference. So let's run our code, and the values that we get when we shift left and then print out each element is 2, 10, and 5, which makes sense when I shift everything to the left and wrap 5 to the end. And then when I do shift right, so after this space, I get 10, 5, 2, which makes sense when I shift everything to the right and then wrap the 10 back to the front. So that's a basic overview of shift algorithms using one-dimensional arrays. So finally, we have an easier algorithm to comprehend. It's a reverse algorithm. So essentially what it does is that it takes the integer array and it returns a new array, but the elements are reversed. So if I were to throw in this array with the values 5, 2, and 10, I should get a new array with the values 10, 2, and 5. If you look at our code, the way I did this was I made a new array the same length as the old one, and using a for loop that goes through the whole array, I basically iterated through the new array forwards while I iterated through the old array backwards. So while I increases, so while I keep accessing the new element in the new array, I'm going backwards from the old array because I'm subtracting from the value r.length minus 1. I'm subtracting the value I. So in the first iteration, this is going to be 0, while this is going to be the last element. In the second iteration, this is going to be index number 1, and this is going to be the second to last element. And it's going to continue like that until it fills up the whole array, and it's going to return that. So using the same strategy I used for the previous methods to print them out, if I were to print it out, I get 10, 2, and 5. So we know that this method works. So that's about it for the algorithms that I'm going to cover, but there's one final thing that I need to show you guys, and it's something called an enhanced for loop. So up until now, we've been printing out our values like this, where we reference the length of the array as the instance variable through dot notation as such, and then to print out each element, we have to reference the array name, so R, and then use the hard brackets and the iteration number I. So that's how we've been doing to print out each element in the array. But what if I told you there's actually an easier way to do this? So instead of using the standard for loop notation, what you can use is an enhanced for loop. So what you want to do is write for, then parentheses, and then here's where things differ. You want to know what type your array is. So my array is an integer type, so I'm going to write an int, and then we want to write a letter or symbol or anything to represent each element in the array. So I'm going to use I. So int I. So same thing as before, but now I'm going to write a colon, and then I'm going to reference the array name, so R. Once I do that, I put in my squiggly brackets, and inside I'm going to print out I. So instead of R bracket I, we're going to print out I. And if we do that, we get 5, 2, 10. So these were the original values, and prints out each element in the array. So when I do int I colon R, what that means is that Java is looking through R and it's seeing that there are elements here that can be referenced. So I becomes each element in the array. Unlike in the standard for loop where I represents the iteration number, so we had to specify R and then bracket I. But here we can just print out I as the element directly. Now I know what you're thinking. Well, why couldn't I just use the enhanced for loop for all these methods before? Well, you could use it for some of them, such as the all positive method or the even nums method. These would work with the enhanced for loop, but none of the other methods would work. And if you want to know why, well, there's several limitations of the enhanced for loop. One of the biggest limitations, though it doesn't concern any of these methods, is that you cannot modify any of the values in the array if you use an enhanced for loop. So as I said before, arrays are a class data type, so if you pass them as a parameter and if you change them, so I didn't change any of them here. Instead, what I did was just make a new array. But if you change them directly, then those changes are saved even after the method ends. But if you use an enhanced for loop, every time we reference I, this is a temporary variable. This isn't actually the value in the array. So if we make any changes to I inside the enhanced for loop, they don't get saved after the method ends. Another big limitation of enhanced for loops is that you can't reference the iteration number. And that powers a lot of these methods right here, such as shift left, shift right, and reverse. All these methods refer to I in different instances other than just counting straight forward. So in the shift left algorithm, I'm referencing the previous element in addition to the current one. Shift right, I'm referencing the next element in addition to the current one. And in the reverse algorithm, I'm keeping track of both forward and backward iterations by using I. But I can't do that with the enhanced for loop. In the enhanced for loop, I can only go forwards. And not only can I only go forwards, but I also must go through the entire array. So you see how with the shift left and shift right algorithms, I don't actually go through the entire array. I start with the second element right here and I end at the second to last element right here. If I'm using the enhanced for loop, I have to go through the entire array. So there are definitely some big issues with the enhanced for loop, which is why I don't even like calling it the enhanced for loop. It's also known as the for each loop, if you prefer that terminology. But in some instances, the enhanced for loop can definitely be a big time saver, especially when we're looking at 2D arrays. And 2D arrays, as the name implies, are just arrays inside of arrays, multi-dimensional arrays. And that is something that we're going to be looking at in the future. Not right now, because it's definitely a little too complicated right now, but this video just serves as a simple introduction to one-dimensional arrays, where we just have multiple elements of the same data type in Java. Anyway, I hope you guys enjoyed the tutorial, and I'll see you guys next time.